Okay, so this is where we left off last time. We had our basic feasible solution and we moved this basic variable over to this cell. And now what's going to be next is in moving the basic variable from here to here, we've changed the value of some of the u's and the v's, and so we have to recompute a few of those. And so let's see where we need to compute those. Um, let's see, it looks like v2 doesn't change, right, because this 12 was defined by the 11 and the 1. But now here I'm going to need 9 to be 11. I'm going to have to change the u3, right? And then if u3 changes, that's also going to change v4. Okay, and so therefore v4 is going to change. So let's go ahead and compute those. And so in our new value here, this 11 is fixed by this guy. So therefore we have 9 plus 11, or sorry, 9 is equal to 11 plus something, and so this something is minus 2. Remember that our u's and v's could be negative, that's fine. But then in this case, if I have 5 and that's minus 2, then v4 is going to have to be 7. Okay, good. And now we recompute the values in the non-basic variables and see if we are optimal. Good, and if we compute those, for example, this 8 is coming from 14 minus 6, right? So that's 8. This is 6 minus 11, which is 5, minus 5. This value is coming from 10 minus 12. This value is coming from 9 minus 7. This value, minus 1, is coming from 7 minus 7 plus 1. Okay. And then the 6 here is coming from 16 minus 10. Okay, so because we have some negative values here, this is not an optimal tableau, and so therefore we have to, let's see, where are we going to move in our next variable? Looks like the y12 position is going to be next. Okay, so we go ahead and bring in our theta, and so remember to add and subtract in the other squares or in the other cells in the loop to make sure that we maintain a balanced tableau. Okay, so therefore if I add theta in this cell, I'm going to have to subtract theta there, then I'm going to have to add theta there, subtract theta there. Okay, so how big can theta be? It looks like theta can be 10. So therefore we'll go ahead and shift 10 units around, and if we do that, this will be our new tableau. Now to see if it's optimal, we're going to have to recompute some of the u's and the v's, right? Because I just changed my basic variable set. Okay, so which u's and v's need to be recomputed? It looks like v2 is needing to be computed because we changed our basic variable to this position, right? And then when I changed that, that also changed u3, and then if u3 changed, that's changed v4. Okay, and so can we see what v2 is going to have to be? Looks like v2 is going to be 6. And then if that changes to 6, then u3 is 3, and then if u3 is 3, v4 is 2. Very good. So now that we have our new u's and v's, now we can compute the other cells. So for example, in this position, we have 14 minus 11, so it'll be 3. And in this cell, we have 12 minus 7, which is 5. 10 minus 12, which is minus 2, and so on. Because we have this negative sign, what does that mean? This tableau is not optimal. And so now we'll bring this cell in and create a loop. So where's the loop going to be in this case? If I make this theta, then this is going to be 30 minus theta. Then I have to come all the way down to here to get a 20 plus theta, then a 25 minus theta, and then I skip over this guy. I skip over it and land here. Okay, because remember, you can't have 3 cells in a row when you're forming a loop. Okay, good. So let's go ahead and write that in red so you can see it. So we're forming this loop, and now how big can theta possibly be here? It looks like theta can be 25 before we start to become negative in the cells. So let's go ahead and make theta equal to 25 and reset our basic variable set. Okay, and that also resets we have to reset our u's and our v's now, right? And so what are those going to be? Looks like we have to reset v1 had to be reset because this is no longer a basic variable. And since that got reset, then that reset u2. And if u2 gets reset, then also v3 must be getting reset. And it looks like the other ones can stay put. Good. Okay, so now how am I going to reset this? Looks like v3 is going to be what? Looks like v3 is going to be 10, right? Then what else? What other cell can be defined? It looks like this one can be defined. Oop, I guess this one can be defined too. Oh, I made a mistake. This one can't be defined, right? Because that is a non-basic variable. So that did force me down here. And then once I get this cell, right, 9 minus 3 is equal to 6. So that forces that to be 6. Good. And that resets my dual variables. And so what's up next? We recompute the row 0 values in the non-basic variable cells. Okay, so for example, in this position, actually in this position we have 8 minus 6, so that's going to be a 2. And then filling in the rest of the variables, what do we see? No negative values. Yay! We have an optimal solution. Very good. And so this is the method we've been advertising. This is MODI, or the UV method. Okay, so go ahead and take a minute and try to do this example. Just take one step in and see if you can find the U's and the V's, and then see if and then determine which cell comes into the basis next, if it's not optimal. Okay, so go ahead and press pause. Okay, we'll continue. Did you get that? I'll let you take a look at that for a second. Pause it if you need to. So we'll continue on. So this is the cell you're going to need to enter next. Okay, very good. And so if you do that, you end up with a 5 in that position. And so you're removing this variable and bringing this variable in. And so if we do that, we get this tableau. Good. And once we've recomputed our U's and our V's, we see that we get all positive values. Okay, so therefore try this out. See if you can repeat this solution and get the same values for the non-basic variables. Good. Okay, this is now optimal. Now I wanted to talk just briefly about degeneracy. So notice when we were filling this in, I've got 1, 2, 3, 4, 5 variables here, but I've got 1, 2, 3, 1, 2, 3, 4. M plus n here is equal to 7. So I need 6 variables to make up a BFS, but I've only got 5. And so what's going to happen is that I'm not going to have enough squares here to solve for the dual. By that I mean, suppose u1 is equal to 0. Then v1 is equal to 4, and v2 is equal to 6, right? And then u2 is equal to 8. U2 is equal to 2, and then that forces this to be 4, right? v3, and if v3 is equal to 4, do you see here? This 50 is here by itself. u3 and v4 have not been determined, so we just have u3 plus v4 equals 50 without any kind of determination. Okay, so we have to decide on which variable will be basic. And so typically it's probably a good idea to put epsilon in that cell, just so you can remember which cell can we determine. We did this computation before. Yeah, we don't want cells here and here because that would create loops. So epsilon here or here would work, and so we're just going to put it in here for an example. And if we do that, that forces us now to fill in the duals. And so once we have the dual values, we can compute the other non-basic variables. And now we can just continue, right? And now we have our choice as to which variable to bring in. I guess we're going to bring this one in first. I guess this one's going to be in first. just to try that out. And now I wanted to show you what happens with this epsilon when you're coming into a loop. Well, you want to think about it as epsilon is a very, very, very small number. And so the most theta can be is epsilon. And so the epsilon just changes from this cell to this cell. 10 minus epsilon is, we're just going to say, is epsilon, and 50 plus epsilon is epsilon 50. And so what we're doing is we're just shifting the epsilon from this cell to this cell, okay, and retaining the rest. Good. And so that changes the values of the dual, and that also changes the values for the non-basic variables. And so everything has been filled in here. So you might pause that and just double check that everything is correct. And finally, we're kind of running out of time, but you might check to see how this new loop is presented, what that's doing, how big can our theta be at this point. Well, theta can be 10 at this point, and as soon as theta is equal to 10, you remove the degeneracy, right? This now becomes a 10 instead of an epsilon. Yay! Okay, I've recomputed the u's and the v's, and double check everything. We have to bring this cell in next. Okay, and then if you do that, you should get this as your basic feasible solution. And this is the optimal solution. So double check this problem and see that you get the same answer. Next is everybody's favorite sensitivity analysis. We're at 11 minutes, so I better stop. See ya later.